Hello, this is session 7 of units and measurement. In this session, we are going to solve the homework problem that I had given you for Neet in the chapter units and measurements. So let us get started. The first problem, they are asking plane angle and solid angle. They want to know if they have dimension as well as unit. Now, we know, I had told you earlier if you remember. Consider a particle moving along a circular path. This is the radius and the particle moves like this. So after a certain time it reaches this point over here, and if this distance is very small, we can consider this as a linear distance s. So this becomes a triangle, a right angle triangle with the angle theta subtended at the center. So we can write sine theta is equal to, this is our right angle triangle, this is the right angle and this is theta. So sine is this divided by this, or s divided by r. So it becomes s by r. And when theta is small, as we know that if theta is 0 degree, our sine theta is also 0. So when theta is much less, then sine theta is equal to theta. Therefore we can write theta is equal to s by r. Now s is the distance travelled, which is also the dimension of length, and r, which is the radius of the circle, has the dimension of length as well. So theta is a dimensionless quantity. Similarly, in case of a solid angle, consider this is a sphere in 3 dimensions. So this will now become a cone. This path will now become a cone, and our solid angle is defined as the angle. If we call the area of this surface as A, then A divided by 4 pi r square, which is the surface of the sphere if the sphere have a radius r. So this is the solid angle. So now area has the dimension of L square, 4 pi is the dimensionless quantity, r square, which is radius square, also have the dimension of L square. So omega, or the solid angle, is also a dimensionless quantity, but both of them have some unit. Angle have a unit. If you remember that solid angle have a unit called steradian, and angle have a unit called radian. So they have unit but they do not have any dimension. So unit but no dimension. This option over here is correct. Now we'll move on to our next problem. In this problem, they are asking the physical quantity that has the same dimension as that of pressure. What is pressure? Pressure is nothing but force per unit area. So force per unit area. So this option cancels out. Force per unit area is ml t to the minus 2 by L square. Momentum also cancels out because momentum is m into v. So this cancels out. What is Young's modulus of elasticity? Young's modulus of elasticity is stress by strain. So Young's modulus of elasticity is stress by strain. Stress is force per unit area by strain. Strain is the amount of deformation, be that in length, be that in area, or be that in length or volume, or a deformation in the body. So therefore this is a dimensionless quantity because strain is the ratio of two similar quantities. Therefore the dimension of Young's modulus is equal to the dimension of stress, which is force per unit area. So this is our answer. Young's modulus of elasticity has the same dimension as that of pressure. We will now look at our next problem. Here they are asking us to consider force, time and acceleration as the fundamental physical quantity, and they want us to find out the dimension of energy in terms of force, acceleration and time. We know that the dimension of energy is force into distance. So we can keep the force, but distance here is not a fundamental quantity. So we have to express distance in terms of acceleration and time. Acceleration is velocity per unit time, Lt to the power minus 2. So we have to find out this L from here. So this L or the distance becomes A by t to the power minus 2, so a t square. So this becomes f a t square. So this option is correct. The problems are very simple. Let us move on to our next problem. Okay, so here they want to know the unit for thermal conductivity. If you remember the equation that a rate of heat flow is equal to some constant into the area into the temperature gradient. Sorry, this is T, the time rate of flow of heat. So heat is nothing but the energy that is in, say, joule. This is time, so in second. This is our thermal conductivity. Area is in meter square, and this is temperature, so Kelvin, by this is length, so again meter. Joule per second, which is the quantity, which is the unit for power, so this becomes a watt. These are looking like the same. Let me write it as small k. So this is Kelvin. This becomes meter, and if you bring it to this side, then the meter comes like this, and this is our thermal conductivity. So our thermal conductivity becomes watt Kelvin inverse meter inverse. So this is the correct option. Sorry, this is the correct option. This was given as joule, so this is the correct option, watt meter inverse Kelvin inverse. Moving on further. Physical quantity of the dimension of length can be formed out of Cg and square by 4 pi epsilon naught. So they want us to find out the dimension of length using these three as the fundamental quantities. Let us consider that the length depends on c to the power x, g to the power y, and e square by 4 pi epsilon naught to the power z. We know that 1 over 4 pi epsilon naught e square by r square is the dimension of force. So e square by 4 pi epsilon naught has the dimension of force into r square. Similarly, g is the universal gravitational constant, and the gravitational force is written as g m1 m2 by r square. So g has the dimension of force r square by mass square. So c is simply with the dimension of velocity, which is Lt to the power minus 1. G has the dimension of force multiplied by r square, so L cube by mass square. This to the power y, and e square by 4 pi epsilon naught is force multiplied by r square, so this becomes like this. So let us bring the powers of L together. L to the power x, L to the power 3y, and L to the power 3z. The power of t is minus x, that from here is minus 2y minus 2z, and the power of m is, this is simply m, so m to the power minus 1 y plus z, and on our left hand side we only have L. So equating the powers from both the side, we get minus y plus z is equal to 0, or y is equal to z. Next, equating the power of t, there is no quantity of t on the left hand side, so this is again going to be 0, or 2z is equal to minus x minus 2y. y and z are again equal, so this is minus 2y, or 4y is equal to minus x. This is another relation. Now we can equate the power of L, and we will get y and z are equal, so this is 6z. We also know the relation between x and y. X is equal to minus 4y or minus 4z, because y and z are the same thing. So z is equal to half, which is same as y, and x is equal to minus 4y or minus 4 into half, which is minus 2. So finally this becomes c to the power minus 2. That means 1 by c square. So these two options easily cancel out. Looking for g to the power y or g to the power half. So this is 1 by g to the power half or g to the minus half. So this cancels out. This is our equation. This is our answer. It was an interesting problem. Moving on further. Okay, we have solved all the problems. So see you in the next session again. If you remember, I had given you some homeworks for error calculation and vernier scale and screw gauge. In our next session, we will solve the problems for those. See you in the next session. Till then, take care. Bye bye.